Okay, how are we doing? All right. So our first story is going to be, first use of this is going to be what's called the median voter theorem. And I put theorem in quotes because it is generally taken a lot more seriously by a lot of economists than it really should be. Not so much political theorists, but people that are adjacent because they learned it in a class like this. God help them. And then they just memorize it sort of as a theorem without thinking it through. But it's a useful thing to think about. And it does capture something reasonably real. It doesn't capture everything, but it captures something real. Okay? So suppose, for example, we've got our little policy space, 1, 0, and we got 3 guys. And I am going to, my initial guys, I'm going to draw as guys, just because it makes me happy. I won't do that forever because it takes forever. But what this is saying is, this is this guy's ideal position. So he's got a utility function with single peak preferences that looks something like that, right? And this is this guy's ideal position. And so he's got a utility function that looks something like this. Right? He's got single peak preferences. And lastly, we got this guy who's got an ideal position, and his utility function looks something like that. All of them have single peak preferences, and the little guy symbol is telling us what that guy's ideal position is. Okay? Okay. I'm redrawing the same thing. 1, 0. I got my 3 guys, which now I'll just do with x's. Those are my 3 guys with their ideal position. And now we're going to have 2 things to vote over. Okay, so we have choices are A or B, and we're going to vote over these things. So let me put A here, and we'll put B here. Okay? And those things come up for a vote, and we got these 3 guys that are going to vote, and they're going to decide everything by majority rule, just like back in the day. See if we can. And what's going to happen? Well, clearly, this guy is going to vote for, well, let me start over here. Let's talk about this guy. This guy is going to vote for B, right? Because he has the single peak preferences. And so whichever one is closer to him, now they're both on the left. And so the farther he moves away from his ideal point, the less happy he gets. So he's going to vote A. I'm sorry, B. He's going to vote B. Nobody stops me when I say dumb things. It's ridiculous. But you thought it. You thought, Ivan, he's just lost the plot. But you didn't say it. They're very polite, very polite. All right. Same thing with this guy, right? This guy's going to vote for B as well because B is closer to A. They're both on the same side, and so utility is going down. The farther he moves away from his ideal point, he goes to the first one, right? And that's B. Okay? So right away, we can see that B is going to win, right? Now, we don't know which way this guy's going to vote, right? Because it depends on how steep his utility curve is. If it's very, very steep on the left and very flat on the right, that's still single peak preferences, but he might prefer B to A. Okay? It looks like if they're symmetric in some way that A would be better. Probably he'll vote A. But if he has those very steep preferences, then he would vote B. But it doesn't really matter because the other 2 guys are going to vote B. B wins. And in particular, the middle guy. Not the far right guy gets his choice too, but in particular the middle guy is going to get what he wants. And we're going to see that the middle guy is always going to get what he wants, and this is going to be the median voter. The median voter is the guy that has the same number of people on the right of him as the left of him. He is always going to get what he votes for. And this is our theorem. So we'll do one more here while we're here. See, add a page. Get 1, 0. We got a guy here, a guy here, a guy here. Now I had one where we had A all the way off to the left. So let's put A here and B here, right? So in that case, this guy votes for A because they're both on the right of him, so he's going to vote for whichever one is closer. This guy is going to vote for B because that's a very sad B. He's going to vote for B. That's still sad B. Okay, you're going to have to live with a sad B. That's life. It sucks to be you. Because they're both to the left of him, so he's going to go to whichever one's closer. And so we got one vote for A, and we got one vote for B. And so whatever the middle guy votes for, that's going to win. Right? And so maybe he votes for A, maybe he votes for B. It depends on the shape of his single peak preferences, which one goes down faster. But whichever one he votes for, that's going to win. Okay. One more to sort of complete the possibilities. If I can ask you to bear with me here. We got X, 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 and let's put A and B here. Right? In that case, this guy votes for B, this guy votes for A, and this guy also votes for B. But again, it's 2 to 1. He gets the thing he votes for. So the guy in the middle is always going to get what he votes for. Okay? So this is the median voter theorem. The guy in the middle is the median voter, got the same number of people to the right of him as the left of him. Everyone has single peak preferences. There's only one policy. We're on this policy line. In that case, the median voter will always get what he votes for, which means we can just treat it like there's one guy. Right? The median voter is going to decide, and this is all a voting thing, but the median voter is going to get it. Okay, I'll leave it there, and we'll continue next time.